For example 7, a golf ball is dropped from the top of a 100-meter building. In each bounce, the ball reaches a vertical height that is 3/4 the previous height. Determine the vertical height of the ball after the 7th bounce. Now remember, at 0, there's been no bounces, so if I'm doing it for the vertical height after the 7th bounce, then n-1 is the number of changes, or n-1 is the number of bounces. So if I want it for the 7th bounce, then in this case, I'm going to take my starting value of 100, I'm going to multiply it by my R value of 3/4, and I'm going to do it 7 times, not 7 minus 1 times. This should give me 13.3 meters to the nearest tenth. If it wants the total vertical distance to the nearest tenth traveled by the ball when it contacts the floor the 7th time, then that means that when it contacts the floor the 7th time, then it has fallen 7 times. Because I started at a height of 100 meters, it didn't rise up to that first term. It has risen 6 times. So I need to calculate for these 2 separate ideas. So how far did it fall? I'm adding up every time that it fell, and I'm going to call that S7. This would give me that starting height of 100 times my R value of 3/4 to the power of 7 minus 1, all divided by 7 minus 1. Now, if you think of how a ball works, that's just for the falling. So that's only accounting for where it's falling. We also know that it's going to rise back up. Now it's actually only going to rise back up 6 times, like I said, but we wouldn't count the rising of the first time. Well, what's the easiest way to solve this? Well, if I said that it rose and fell 7 times, then I could say that the total height would be double the series for 7 and then just take away that initial rise of 100, which never actually happened. This is going to give you 593.2 meters. When it says, how many times does the ball need to bounce to travel approximately 675 meters for this total distance, then I'm going to say that if I had 675 is equal to that formula that we just had, 2 times 100 times 3/4 to the power of, in this case, n minus 1, because we don't know how many, all divided by 3/4 minus 1, and then I subtract 100 from it, I'm still just isolating for n. I would start by adding 100 to each side and saying that 775 is equal to 2 times all of this. The second thing that I'm going to do is I'm going to divide both sides by 2, and that's going to give me 387.5 is equal to 100 times 3 over 4 to the power of n minus 1, all divided by 3 over 4 minus 1 would be the same as negative 1/4. If I need to multiply both sides by that negative 1/4, then I'm going to get negative 96.875 is equal to 100, 3 over 4 to the power of n minus 1s. Divide both sides by 100, and negative 0.96875 is equal to 3 over 4 to the power of n minus 1. And when I add 1 to both sides, I'm going to get positive 0.03125 is equal to 3 over 4 to the power of n. At this point, I can guess and check, but it's not really going to work. So I'm likely going to graph this out on my calculator. y1 is equal to 0.03125. y2 is equal to 3 over 4 to the power of x, and x is going to be approximately 11 bounces. For example 8, consider the geometric series defined by Sn is equal to 5 times 3 to the power of n minus 1. Find the first 4 terms of the series. Well, then I can just sub in the values for n. S1 is equal to 5 times 3 to the power of 1 minus 1, or 10. S2 is going to equal 5 times 3 to the power of 2 minus 1, or 40. S3 is 5 times 3 to the power of 3 minus 1, or 130. And S4 is 5 times 3 to the power of 4 minus 1, or 400. We know from our arithmetic that S1 is equal to term 1, or alternately, term 1 would always be the same as S1, which in this case would just be 10. Term 2 is S2 minus S1, or 40 minus 10. Term 2 is 30. Term 3 is S3 minus S2, 130 minus 40 is equal to 90. And term 4 is S4 minus S3, or 270. When I list out the sequence, 10, 30, 90, 270, I can see that common ratio of every single time I'm just multiplying by 3. If it says that term 9 is what I want, then I could do that by saying that term 9 is equal to the sum of the first 9 minus the sum of the first 8, And given the formula I was given, I would say that that would be 5 times 3 to the power of 9 minus 1. Subtract from that 5 times 3 to the power of 8 minus 1. And I can solve right away that that term is going to be 65,610. If I want the common ratio in a geometric series, it says that scientists plate E. coli bacteria on a petri dish. At the end of the first 30 hours, bacteria cells are present. The number of new bacteria cells produced each hour forms a geometric sequence. If the total of 40,950 bacteria cells are present at the end of 6 hours, use technology to determine how many bacteria cells are produced produced in the 6th hour. So what do I know? I know that my first term is 30. That's after 1 hour. I'm trying to solve what term 6 is, but I don't really know it. I do know that the sum of the first 6 terms is 40,950. And I don't know what my R value is. Well, based on the information I have and what I'm trying to find first, I have a formula that works for that. I know I have a sum formula that states that my first term multiplied by my common ratio to the power of n minus 1 divided by my ratio minus 1. And I know, because it's the sum of the first 6 terms, that my n value is 6 in this case. I can sub all this in to solve for what my R value is. If 40,950 is equal to 30 times R to the power of 6 minus 1, all divided by R minus 1. Then all I need to do to solve for what R is use my calculator and graph. Y1 is the left side. Y2 is the right side. And instead of using R, I'm going to call R X. I'm going to solve for where these intersect and see that where they intersect, X is equal to 4. If I know that my R value is actually equal to 4, then I can solve what T6 is by stating that that's going to be term 1, which we already know is 30, times the common ratio of 4 to the power of 6 minus 1. T6 is 30,720, so 30,720 new bacteria cells are produced in the 6th hour. And that's it.